Okay, so 5-3, we're going to continue working on solving equations. The next 2 days, you're going to the assignment, you're going to work on class, and it's due at the end of the period online tomorrow. I won't be here. I will leave the worked out solutions. It is all odds, so you have Cat that can help you. You have each other. Yes, sir. Okay. So I have 2 cosine squared minus x and then minus 1. I would suggest putting those parentheses around that x so you know what you're taking the cosine of. So what should I do first? Add the 1 and divide by 2. Can we do that all at one time? Yeah. Okay. Add the 1, divide by 2. So I have 1/2. So now what?
Square root.
Square root, both sides. So I have cosine of x equals what?
Square root of 2 over 2.
Nope.
Could that be square root of 1 over square root of 2?
Nope.
No, I'm just saying, with the square roots.
You're missing something.
Pi over 2.
It's square root of 2 over 2, but you're missing something.
Rationalize?
He did.
Square root of 2 pi over 2.
When I take the square root of something, the answer is what and what? Plus or minus.
Yeah.
So this would be 1 over the square root of 2, or Kale said plus or minus square root of 2 over 2. So that's all 4 quadrants, isn't it?
Yeah.
Because we got all 4, because it's plus and minus.
Yeah.
So quadrant 1, which is the reference angle, correct?
Yes.
Quadrant 2. So this would be positive, this would be negative, and then I'd have quadrant 4 would also be positive, and then quadrant 3 would be negative, correct? What? What's what? Okay. So square root of 2 over 2. What angle? Radians?
Pi over 2. Wait, pi over
4.
Pi over 4. It's 45, right?
Yeah.
Okay. So now I need the 45 in all the quadrants. So one less than a whole pi would be what?
Negative 3 pi over 4.
It would just be 3 pi over 4, not negative. Like this was the sign form, not the answer was negative. Does that make sense? Okay. And then
7 pi over 4 for quadrant 3.
7 pi over 4
Quadrant 4.
would be quadrant 4.
And quadrant 3 would be 5 pi.
And 5 pi over 4. So don't forget what when you take the square root. Plus or minus. Questions?
No, that one is easy mode.
No. Second quadrant is 1 less than a whole pi, 1 more than a whole pi, and 1 less than 2 whole pi. So you're not adding like this is pi. So here is pi plus your reference angle. Here is 2 pi. So it's 2 pi minus your reference angle. Here it's pi minus your reference angle. If you want to think about it that way. 1 more, 1 less, like we've been doing.
Okay, so quadrant 1 is 1 above.
Quadrant 1 is the reference angle.
Yeah, but like I'm just like saying it's the first one, like of that radian,
Yes.
and then the rest is like
1 less, 1 more.
Yeah.
Yep. Cotangent x, cosine squared x, 2 cotangent x. What would you guys like to do?
Could you change the cotangents to cosine over sine?
You could.
Back to cotangent, so we just have equals cotangent.
Yeah.
What did you say?
Subtract
Right.
cosine.
No,
Okay.
you can't because
No,
they're not.
Yeah, you can't that. But I could do this over. Oh, I hit it before I had my marker. Okay. Now, I just heard it, and I'm going to tell you no, because yesterday I bet you didn't pick up on it. I said you could move a function, you could change it to another function, but can I get rid of a function?
No.
No. If I divide by cotangent, do I get rid of a function?
Yes.
Yes.
No. Yeah, you do.
If I divide by cotangent, do I get rid of a function?
Yes.
What function do I get rid of?
Cotangent.
Cotangent. I can't get rid of a function. So I can move it, I can change it to another function, but I cannot eliminate it. So probably want to move this over here.
So subtract it over.
So subtract it over. So I have cotangent cosine squared minus 2 cotangent equals 0.
Would you change the cotangent, like cosine over sine, and get common denominators or something?
I wouldn't, just because I have a cotangent in both terms. I have a cotangent in both terms, what can I do with it? I can factor it out, can't I? Now, if I didn't have it in both terms, I might go that direction, but here I have both terms, so I could just factor it out, make my life easier.
Okay.
So I can factor out a cotangent, and then I'm left with cosine squared minus 1.
2.
Oh, 2, thank you. Equals 0. So now at this point, can I set both of those things equal to 0?
Yeah.
Yeah. So I have cotangent of x equals 0, and I have cosine squared equals 2, correct? I forgot my x. So the cosine squared, I have to take the what of both sides? Square root. So I have cosine of x equals
Equals plus or minus.
plus or minus the square root of 2. And then I have cotangent is 0. So we can do the cotangent of 0 without a calculator, correct? Can I do this one without a calculator?
No.
No. You know square root of 2 over 2, but you know square root of 2 over 1?
No.
No. So I'd have to use a calculator on it, wouldn't I? Okay. So this one, cotangent, so we're thinking our circle, right? Cotangent is the reciprocal of what?
Tangent.
Tangent. So I'm looking for the tangent to be undefined.
Yes.
Because what's the reciprocal of undefined?
0.
0. So I'm looking for tangent of x to equal undefined. And tangent is what over what in terms of x's and y's?
Sine over cosine.
In terms of x's and y's?
X over
X over Y.
Y over X.
Y over x, sine over cosine.
Oh wait, yeah.
So I need x to be 0 for it to be undefined, yes? Where is x 0 at?
X is 0 at 1.
Pi over
Well,
2. and
At
3
pi over 2 and
3
3 pi over
3 pi over 2. X is 0 here and here, correct? So my two answers here are pi over 2 and 3 pi over 2. Now I said I needed a calculator, and I'm going to need to find the first quadrant, which is my reference angle, correct? And then for the second quadrant, I'm going to take pi minus my reference angle, correct? The third quadrant, I'm going to take pi plus my reference angle. And the fourth quadrant, I'm going to take 2 pi minus my reference angle. So I've got to find my what?
Referencing.
Reference angle. Anybody remember how to find an angle on your calculator?
Mode. Do we need to put it in radians?
We need to have it in radians, yes. So make sure you're in radians. And how do you change it to radians?
Mode.
Mode.
Go down to radians.
Make sure it's in radians.
And then don't we do math?
No.
I need to switch the domain and the range.
Inverse is fine.
Inverse. So inverse of what?
Inverse.
Cosine.
Cosine. And then put square root of 2.
Syntax error.
Make sure we.
Oh no.
Oh no.
No, inverse is how you find the angle and side, wouldn't it?
That's what we know. We want the angle. We did that right. Why is it telling me error?
Because you can't find the inverse of a square root.
No, you can.
Define.
It doesn't say, I mean, it says value entered is not allowed in the function or command.
Did you forget to switch?
I didn't.
Can
No.
you not take the angle of it because it's a square root?
Okay, I'm going to ask you a question. What's this point right here?
Or you, I don't.
What's
One.
1 and
2 is greater than
0, right?
Okay.
What's this point right here?
0, 1.
Negative 1, 0.
Negative 1, 0.
Oh, yeah.
And this graph, remember, looks like this. Yes? And what's this max up here?
1.
1. And what's this minimum down here?
1.
Negative 1. Because we have 1 and negative 1, yeah?
Oh, it's outside the graph. It's outside
What's the square root of 2?
greater than 1.
Is it greater than 1?
Yeah.
So is that in the domain? No. So for this, my answer for here is no solution. Square root of 2, or plus or minus square root of 2, is out of the what? Domain. And that is your answer. Like, I have to see that whole thing. I don't have to see this because it's out of the domain, but I have to see no solution plus or minus square root of 2 is out of domain.
How did you put that in your calculator?
I put inverse cosine of square root of 2.
So if it gives you the error, then no solution.
Well, you got to make sure you put it in right. I wouldn't automatically assume that. So if it gives me an error, and I should know square root of 2 is bigger than 1, correct?
Yeah.
Okay, if for some reason you don't know the number, I would take off the function and just put the number in there, your calculator. But do not assume that just because it says error that it's no solution, because you could have just put it in wrong, correct?
Yes.
Yeah.
So you better check. So is everything going to be a solution?
No.
No. These are called extraneous solutions. What's extraneous mean? What's extraneous sound like?
Extra.
Extra. They're extra solutions. Okay, what about here? Sine squared x equals 2 sine.
Could you
Subtract the 2 sine over.
Subtract the 2 sine over. Now, guys, it's just like when you learn to solve equations in algebra. Could you do an example of every single one you were going to do? No. You just have to use your algebra rules. I cannot do an example of every single one you're going to get hit. But you're going to use what you learned from your manipulation in your functions and what you know of your algebra to solve these.
Factor out a sine.
You definitely would factor out a sine. If it was 3 terms, you would do polynomial factoring.
So sine
Set it equal to
So it's
0.
sine
minus 2.
of x times sine of x minus 2.
Set equals 0.
And both of them equal to 0, so I have sine of x equals 0. And sine of x equals 2.
Wait, can that work?
Can that work?
Yeah.
No.
Wait, no.
Because
Sine
of
looks
x
like this.
And the domain's 1 to
1
To
to
1.
negative 1. So does this one work?
No.
1. No.
Nope. So this one right away is no solution.
2 is outside the domain.
2 is outside the domain.
Is the other one gonna work?
Is sine 0?
Yeah.
Yeah, I see it how many times?
2 times. 3.
I see 3 times. Watch your domain though, because I think your domain's on these, and I don't have my domain written. I need to look at it. I'm just gonna look in your assignment, I guess. Okay, so your domains on these, it says just solve. It doesn't say what the domain is. So I'm gonna show you how to find like one revolution and then all revolutions, because some of them do. If it said 0, 2 pi, okay, what is my domain?
1 revolution.
1 revolution. Is 0 included?
No.
Yes.
Yeah.
Is 2 pi included?
Yes.
Yes.
No.
Oh,
Why not?
Not clear, because it's an open circle.
It's a parenthesis. So on this graph, I wouldn't have 3 answers. I would only have what?
2.
These 2. Because isn't this the same as that? Okay, so I'm going to show you how to do a problem. This is 1 revolution and then all solutions.
What do you mean that third mark is the same as the first?
Because this starts over.
Oh, okay.
Okay, so where is sign 0 at?
0
0 and
and pi.
pi. Okay, so this is for 0 to 2 pi. Now all solutions. Okay, so all solutions means every single time. This keeps going, right? Yes? Okay, so this one here is the same as this one. How far apart is that?
2 pi.
2 pi. 1 revolution, right? And then to get another one to be another 2 pi. Correct?
No.
So I'd have 0 plus or minus 2 pi n. But you don't want to write 0 plus or minus 2 pi n. That looks funny, right?
Yeah.
So you just write 2 pi n.
Yeah.
Okay? So I got this big old mess up here. I'm going to erase because that's a mess. So now we have our second one we need to worry about, which is pi, right?
Yeah.
So, okay, so here's pi. And then there's,
2 pi.
well, that's 2 pi, but then this is 3 pi.
Yeah.
Yeah.
Okay, so how far is pi and 3 pi?
2 pi.
2 pi's. But the first one was at where? Pi.
Pi.
So it's
plus or minus 2
pi
and plus
plus or
pi.
minus 2 pi n. Because this is the first one. Why didn't we put 0 in front of the other one?
Because
Why?
it just looks bad.
It's bad form, right? If n is 0, am I going to get 0? Yes. But over here, I have to start where?
Pi.
Pi. So if I got an answer of pi over 3 and 4 pi over 3,
There's F.
so all would be pi over 3 and then plus or minus 2 pi n,
Yeah.
and then 4 pi over 3 plus or minus
2 pi n.
2 pi n. And if it's only pi apart, like for tangent, because tangents, the period's only pi, right?
Yeah.
So it wouldn't be 2 pi n, it would just be
Pi.
pi n. I am more worried about this solution. We can work more with the all on Monday if you're struggling with the all.
Do we need to include the bracket 0?
No, that's just to tell you this is 1 revolution.
God.
What is?
What is what?
I don't know. What does that? What does that mean?
What does what mean?
The one that you circled.
This is 1 revolution. That's just to 2 pi. Like nothing else over here or over here exists. These are all so when it continues both directions. So this means 0 is included and 2 pi is not included. Because in our circle, when I hit 2 pi, am I back at 0?
Yeah.
Yeah. So you don't include it twice.
If 2 pi was included, then would it be just
If 2 pi was included, you'd have 3 answers.
Yeah.
You'd have 0 pi and 2 pi. But they're not going to include both. Now they could do 0 is not included and 2 pi is included. I see that a lot.
And how would you do that?
This would just be 2 pi,
Okay.
and your all solutions would still be 2 pi n.
Oh, okay.
So you got to see where the bracket is at. Or sometimes they'll write it 0 is less than x, which is less than equal to 2 pi. So here 2 pi is included, or I could have 0 is less than equal to x, which is less than 2 pi. So they can write it like an inequality or interval, either one. The book usually does interval because it's easier to typeset, but either one. Quadratic types we have here. We can factor this, correct?
Before.
We could factor this, yes?
Yeah.
We could factor this, yes? We could factor this.
Yeah.
We could factor this.
Yes.
So you are going to be factoring. The reason why I have parentheses around this is because it's this whole thing. This right here is basically this problem.
Yeah.
What is my x?
X.
Is sine x.
Yeah.
Does that make sense what I'm saying?
Yeah.
So if I were to factor this, I'd take 1 times 2, right? So factors of 2 that have a difference of 1 are what?
1 and 2.
1 and 2. So it'd be 2 sine and sine, right? There's my 1 and my 2.
Yeah.
And the factors of 1 are 1 and
1.
1. And we need the 2 to be negative, right? So this one has to be negative,
Uh-huh.
and this one is
Positive.
positive. So set them both equal to 0. So you have sine of x equals negative 1/2, and sine of x equals 1. But you factored when you were proving, correct?
Yes.
Are you going to have to factor when you solve?
Yes.
Yes. Are you maybe going to have to do a quadratic formula?
Probably, yeah.
Probably. You want to do a quadratic formula?
No.
Yes, so that we know how to do it.
Okay.
I have a question though.
What?
Can we just take out like the sine or secant or whatever this thing is and then just add it back in the end?
In your brain, you should be doing that. I wouldn't do that on your paper. You need to get used to seeing it. In your brain, this whole thing should be x. That should be, you should see 2x squared minus x minus 1. Okay? So we're going to do the same one using quadratic formula. Because I can, right? Instead of making it x equals, it's going to be what equals? No.
A.
What is x? What is x in this problem? Sine of x. So it's sine of x equals. Instead of x equals. And everything else is the same. It's just the coefficients. A is what?
A is
2. B is
1.
1. And C is negative 1. Actually, they're both negative 1, right? So quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I would have 1 plus or minus the square root of 1 minus negative 4 times negative 1 would be plus 4 all over
4.
2.
4 because 2 times 2.
Oh, 2a, yes. Thank you, 4.
A is
So 1 plus or minus square root of 5 will
Oh, I forgot to multiply this by 2.
so that's 8.
Okay, sorry. So this is 9. 1 plus 8 is 9. What's the square root of 9?
3.
3. So 1 plus or minus 3 over 4. So 1 plus 3 is
4.
4. And 4 over 4 is
1.
1. And 1 minus 3 is
2 over 4.
so negative 2 over 4, which is negative 1/2. So you have sine of x equals 1 and negative 1/2. Is that what you have over here? Did I do it exactly like if it was an x?
Yep.
Yes. But it's not x, it's what?
Sine of x.
Sine of x.
Your B's look like 6s, Mrs. Beck.
They do indeed look like these.
Oh well.
Or what?
For B.
Am I good?
No.
But then I didn't answer it. But over here, you'd have to just... On this one, how many answers am I going to have? Because it's negative.
2.
Nope.
4.
3.
Oh. That was close.
If it's negative, you always have to tell me the what angle?
That was Ethan.
The reference angle.
Yeah.
So you would have the reference angle, and you would have a third quadrant angle, and a fourth quadrant angle. And over here, you'd have how many answers?
2,
1.
1.
Because it's positive 1, it's a quadrantal,
Oh, yeah.
and it happens right there, so it's pi over 2. Okay, so it says solve. Oh, we just did. When you have a quadratic, you're going to have to factor or use the quadratic formula, correct?
Yeah.
That's what you're going to have to do. So let's do one we haven't done. Okay, so this one's good because I have 2 sine squared x plus 3 cosine x minus 3. Well, if it's a quadratic, we have to factor, but we have a problem.
Quadratic formula.
They're not the same.
They're not the same functions, are they?
Oh, no, they're not.
So can we write them in terms of one or the other?
Yeah.
Yeah.
Which one can we change?
Sine squared.
Because it's sine squared, I can change that into cosine, correct?
Yeah.
What does sine squared equal?
Cosine of a squared minus 1.
1 minus cosine squared.
Yeah, I said it right before. We took an hour yesterday to figure
It didn't take an hour, it took like 10 minutes. I don't understand.
It took
people
way
are
too long.
so mean.
Okay, so now what do I have to do?
Distribute your 2.
I distribute my 2.
So 2.
So negative 2 cosine squared,
No, wait.
yes, plus 3 cosine. I'm just simplifying.
Minus.
And this would be 2 minus 3 would be what?
Negative 1.
Negative 1.
That's what
Okay, I don't want a negative cosine squared, do you?
factor out a negative.
Factor out a negative. So that gives me 2 cosine squared minus 3 cosine plus 1.
Yeah. Now quadratic formula? Or,
Well, you have fun, but I can factor that.
oh, yeah.
I've had students that like the quadratic formula because they don't want to think about factoring. Okay, 2 times 1 is 3, right?
Uh-huh.
Factors of 3,
What? 2 times 1 is
2, I'm adding. Factors of 2 that add to 3.
2 and 1.
To add to negative.
2 and 1. Well, yeah, they're both negative.
What about 1 and 2?
2 cosine.
So 2 cosine minus 1
Yeah.
and cosine minus 1.
2.
No. The 2 is here.
No. Your factors of 2 that add to negative 3. You need a negative 1 and negative 2. To get
No,
that middle term
my
to
2
zero.
is right here. The factors of this are here and here, correct? The factors of this are here and here. 2 is not a factor of 1.
How did you mean one of those being negative? It's negative 3.
They are negative. They're both negative.
They're both supposed to
Because this is positive, they both have to be negative.
Did you get
Watch. Cosine 2 cosine squared minus 2 cosine minus cosine plus 1. 2 cosine squared minus 3 cosine
Rock my brain.
plus 1. Okay.
They will return some of that.
So that would be
Yes.
Did you get the negative 2 cosine squared from, I know you distributed, what would it have been? 2 minus negative 2 cosine squared.
I just did this first because that's going to go first.
Oh, I forgot my 2 up front.
My squared's going to go first.
I I forgot my 2 in front of the cosine. that's
Okay.
why.
What?
The cosine squared is going to go first. So I did it first. So I took 2 times cosine squared and got negative 2 cosine squared.
Okay, but where'd your positive 2 go? from?
Because 2 minus 3 is negative 1.
Okay.
I just didn't show every little step. Okay, so right here, cosine equals what?
Cosine equals
1 and
1/2.
so where's cosine 1 at?
1 is at the quadrangle.
1 of the quadrantal.
Pi over 2. I mean, pi over 2.
How about 0?
Yeah.
Cosine is x.
Yeah.
Okay, where's cosine 1/2 at? It's going to be quadrant 1 and quadrant
Quadrant 1 and quadrant
4. 4. Cosine is x.
Yep.
Okay, so what is adjacent to 1? What angle is adjacent to 1? Pi over 3. And so this would be 5 pi over 3. So I've got 0. Now these are just 1 revolution. If I wanted to make it all, I'd add what? Plus or minus 2 pi n?
Yeah.
Because this one doesn't say from
Blah, 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 blah.
0 to 2 pi, then the assumption is it does all. On the test, if I don't tell you all, don't tell me all. Okay. I think it's kind of annoying. You've got like 10 problems where they want you to write this every single time, and I think that gets annoying. You get the gist after a few.
Yeah.
Do we have to write the plus or minus? 2
Do it on like every other one of those, so you know. I don't. Am I good?
Yeah.
Okay, what am I going to do with this one?
Cry.
I got cotangent and I got cosecant. Do they have an identity where they go together?
Yes, your cotangent. You can make it
I have 1 plus cotangent squared equals what?
cosecant.
Cosecant squared. So I'm probably going to change what to what?
The cotangent to cosecant.
I'm going to change cotangent to cosecant because the cotangent is squared and the cosecant is not squared, correct?
Yeah.
Okay, so if I move that over, that would be cosecant squared minus 1
Yeah.
minus 5 cosecant minus 7.
Yeah.
Okay, I'm going to see just a second. I'm going to... Okay, that's my last example, so we'll do it. I didn't want to, like, keep going if that was something that was... Okay, so now what do I need to do?
Put the 2 in.
I need to distribute the 2, yes? So I get 2 cosecant squared
Minus 2.
minus 2, but we're going to do that in a second.
Minus 9.
So minus 5 cosecant, and then minus 2 minus 7 is minus
9.
9 equals 0. So I need factors of 18 that have a difference of 5.
No. Wait.
No, there aren't any.
What got it for me?
So I have to use quadratic formula.
Where?
Where'd I get? A times C.
Where'd your negative 2 go? Oh, never mind. I'm just overthinking.
Okay, quadratic formula. So we've got A, B, and C, yes? So it's cosecant of x equals 5 plus or minus the square root of 25 minus 4 times negative 9 times 2,
Yeah.
all over 4? 2a.
Yeah.
Okay, so 36 times 2 is 72. And so 25 plus 72 is 97.
So it stays.
Yeah.
over 4.
Yeah.
So,
Would you break the 97 down?
isn't 97 prime?
Yeah, you're right.
I'm pretty sure it is.
It is.
Okay, so I'm not going to do cosecant in my calculator. I'm going to do what? 1 over sine, or sine of x equals, what is the reciprocal of this? 4 over 5 plus or minus the square root of 97. So in my calculator, I'm going to put inverse sine of 4 over 5 plus the square root of 97. That is going to give me my reference angle, and then I'm going to add and subtract to get all 4 quadrants.
It says error domain.
Error domain. Well, if it says error domain, that means this is probably bigger than what? 1. So put just 4. Well, I'm wondering if you did it wrong. Put 4 divided by parenthesis 5 plus the square root of 97. If you didn't put your denominator in parentheses,
If you do it right, there's an answer.
if you do it right, there should be an answer. Make sure you put your denominator in extra parentheses.
0.269.
Okay, so there should be an answer, right? So now you have to do the inverse sign of what you just did.
What do you mean?
The inverse, because we didn't do inverse sign. So inverse sign of 4 divided by parenthesis 5 plus the square root of 97. You guys should start on your assignments at home tonight. You're not going to have time to finish tomorrow. So the reference angle is a 2.7.
Yeah.
And then you would add and subtract that from pi and 2 pi.
2 pi, why?
Because you have to get all 4 quadrants because you have plus and minus.
Oh, yeah. So you have to make it.
So you have quadrant 1 is approximately 0.27. Quadrant 2 is pi plus 0.27. So that's 3.41. Quadrant 3. Oh, wait, this is quadrant 3.
He asked me if I would be bummed out if we did it
So
right.
since that's what I was signed, we have to be, so it'll be, quadrant 1 is positive, 2 is positive, 3 is negative, 4 is negative.
It doesn't. No, it'd be the same as sign. So positive, positive, negative, negative.
Yeah, so I meant positive, positive, negative, negative.
Yeah. Bye. But the answers aren't negative. The angles aren't negative.
So then
These are the answers.
quadrant 3 would be
So how do you
pi
find quadrant 2 and quadrant 4?
plus.
This is pi. This is pi minus your reference angle. And then this is 2 pi minus your reference angle.
Is it quadrant 4 was?
Yeah.
Tell me, want to put this away?
So pi minus 0.27. Okay, guys, I'm still recording.
Sorry. Oh, sorry.
Is 2.87.
Okay.
And then quadrant 4 would be 2 pi minus 0.27, which would be approximately 2.01 or 6.01.
Fair enough.
Okay. And that was all of our examples except that really weird one, which I think I put it in the computer wrong. Like I think I typed it in wrong.